Good day everyone, and welcome to where we are putting together solutions to those math and science problems that students are encountering. In this video today, we'll be looking specifically at CSEC Mathematics and the topic of algebra. We'll be looking at the questions in this topic that comes in the section 1 of the paper, and in this video we'll be looking at the past paper questions from May 2019 until the present. Feel free to like the video and add any comments down below so we can help you by making other videos in the areas that you are struggling with. Don't forget to look at the description down below where we have outlined the order which we suggest to cover the entire CSEC Maths syllabus in order for you to get a better understanding and therefore a better grade. Let's recall the 10 major topics in CSEC Mathematics, and this video deals with topic number 6, algebra. Algebra can be split into two parts. Into the algebra question comes in section 1 and the one that comes in section 2. In this video, we'll be looking at the ones that come in section 1. That is tested for 6 marks or 6 questions out of these possible 60 questions in the multiple choice, paper 1. And for one full question worth 9 marks now in this new syllabus, out of 100. We will be also looking at some of the directly and indirectly proportional questions which occurred between the years of 2009 and present, which we did not do in the other videos, and which was not tested in the algebra question, which normally comes as number 2. May 2010, number 4a. When y varies directly as the square of x, the variation equation is written as y is equal to kx squared, where k is a constant. Part 1. Given that y is equal to 50 when x is equal to 10, find the value of k. So let's write our formula, y is equal to kx squared, and out of those 3 items, y, k, and x, we have 2 of them. So let's substitute. So 50 is equal to k times 10 squared. So 50 is equal to k times 100. As such, k is equal to 50 over 100. So k is equal to a half. So part 2, calculate the value of y when x is equal to 30. So let's rewrite the equation, y is equal to a half x squared. Remember, we no longer need to write k because we know what k is. And we can substitute x is equal to 30, so y is equal to a half by 30 squared. So y is equal to a half by 900, which means y is equal to 450 when x is equal to 30. May 2013, number 5a. The incomplete table below shows one pair of values for a and r, where a is directly proportional to the square of r. So look at the table we have. We have a is 36 and r is 3. When r is 5, we're not sure about a. When a is 196, we need to find out what r is. Part 1. Express a in terms of r and a constant k. So if we go back to the top line, we see that a is directly proportional to the square of r. So we can say a is equal to k times r squared. And the times is understood, so we don't need to write that. Part 2. Calculate the value of the constant k. So to find k, if we look at the equation, there are 3 values, a, k, and r. And to find k, that means we need to know a and r. So if we look at our table, the first pair, we know a is 36 when r is 3. So let's write the formula, a is equal to kr squared. And let's substitute 36 is equal to k times 3 squared. So 36 is equal to k times 9, which means that k is equal to 36 over 9. As such, k is equal to 4. So copy and complete the table. So as to complete the table now, we need to work out a when r is 5. Now we have our formula, a is equal to 4r squared. We no longer need to write k because the constant of proportionality for this question is 4. And if we substitute, let's look at the third column coming down here. We know r is 5, but we don't know the a value. So we can substitute a is equal to 4 by 5 squared. So that's 4 by 25. So a is equal to 100. So let's bring that up in the table. And let's look at the last part. A is equal to 4r squared. That's our formula. And we can substitute. We know a is 196. So 196 is equal to 4r squared. And the 4 is multiplying. When I carry it across, it will divide. So it'll be 196 divided by 4 is equal to r squared. which works out to be 49. So r is equal to the square root of 49. So r is equal to 7. And we can bring that up in the table as well. So we found both values that were missing. May 2019, number 4a. The quantity p varies inversely as the square of v. Using the letters p, v, and k, form an equation connecting the quantities of p and v. So since they vary inversely, then we can write the equation p is equal to k over, what is it varies inversely with? V squared. Part 2. Given that v is equal to 3 when p is equal to 4, determine the positive value of v when p is equal to 1. So there are a couple different ways to do this. And if we look at the formula p is equal to k over v squared, notice that we have p and we have v. So if we substitute in there, we can find k. So let's do that. 4 is equal to k over 3 squared. So 4 is equal to k over 3 squared is 9. So k is equal to 4 times 9, which is 36. And if we know k is 36 for the rest of the question, then we can say p is equal to 36 over v squared. And the question is asking us to find the positive value of v when p is equal to 1. So let's substitute. 1 is equal to 36 over v squared. So we could carry the v squared from the denominator across. It will multiply. So we get 1 times v squared is equal to 36. V squared is equal to 36. So that means v is equal to the square root of 36. So v is equal to plus 6 or minus 6. So there are two values. And if they're asking us for the positive value of v, then v is equal to plus 6. And we don't need to write the positive sign. It's understood. So we can just say v is equal to 6. May 2019, number 2a and b. Simplify completely. Part 1. 3p squared times 4p to the 5th. And for some people, they can watch it and write the answer completely. And for others, they get some problems. So let's expand it so you can see. 3p squared can be written as 3 times p times p. The multiplication sign is not necessary. Times 4p to the 5th would be 4 times p 5 times. So we can multiply the coefficients, 3 times 4. And p, we have 2 before plus 5 more. So 3 fours are 12, p to the power 7. Part 2. 3x divided by 4y cubed divided by 21x squared all over 20y squared. And if we're dividing fractions, how do we rewrite it? It will be equal to 3x over 4y cubed, and the division becomes a multiplication sign, and the second set of fractions will get its reciprocal. So it will be multiplied by 20y squared all over 21x squared. And we can cancel, or if we want, we can write all together. So let's do that. 3 times 20x by y, all over 4 by 21 by y, 3 sets of y since it's y cubed, by x. And we can say 4 into 4, 1, 4 into 25, 3 into 3, 1, 3 into 21, 7. And x on top will cancel with one of the x's below, and 2 of the y's on top will cancel with 2 of the y's below. So what we are left with? 5 as a numerator over 7xy. Part B. Solve the equation 3 over 7x minus 1 plus 1 over x is equal to 0. So maybe the easiest thing for students who are getting problems is let's put brackets around the denominators. So we will write it with the brackets. And now how do we handle two sets of fractions being added? What we do is we find the LCM, or simply we can multiply the denominators. So it will be x times 7x minus 1 in the denominator, and 7x minus 1 into that is x, so we're left with 3 times x, plus 1 times x into the denominator, x cancels s, will be 7x minus 1. So it's following the same format as if we were doing addition of fractions. This is just addition of algebraic fractions. And now what can we do? We can expand it up. 3 times x is 3x, plus 1 times 7x is 7x, 1 times minus 1, minus 1. All over x by 7x minus 1. And we can simplify it up. 3x plus 7x will give us 10x minus 1 all over x by 7x minus 1. And we can multiply both sides by the denominator. So if we multiply by x by 7x minus 1 on the left-hand side and the right-hand side, well, what will happen is the left-hand side, the denominators will cancel, and 0 times anything on the right side is 0. So we're left with 10x minus 1 is equal to 0. As such, if we want to find for x, let's carry the 1 across. So 10x is equal to plus 1. And the 10 is multiplying when we carry it across. X is equal to 1/10. So when x is equal to 1/10, the original equation 3 over 7x minus 1 plus 1 over x works out to be 0. May 2019, number 2C. When a number x is multiplied by 2, the result is squared to give y. Part 1. Express y in terms of x. So y would be equal to 2x all squared. And you can expand that, 2x times 2x, 2 2s are 4, and x by x is x squared, so y is equal to 4x squared. Part 2. Determine the two values of x that satisfy y is equal to x, which is a straight line, and the equation in C part 1, which is a quadratic. So when a straight line intersects a quadratic and there are two values of x, it means there are 2 points of intersection. So it's like saying, let's solve the pair of simultaneous equations. And let's say the first equation, y is equal to 4x squared, and the second equation, y is equal to x. So there are a couple different ways we can solve it. So what I'll do, I'll use substitution, where I'll substitute equation 2 into equation 1. Now y is equal to x, and y is equal to 4x squared. As such, x is equal to 4x squared. And let's carry the x across. It's plus x on the left-hand side. When we carry it across, it becomes minus x. So 0 is equal to 4x squared minus x. And we can factorize out the x. So 0 is equal to x by 4x minus 1. Thus, either x is equal to 0 or 4x minus 1 is equal to 0. And we could carry it across. 4x is equal to 1. So x is equal to 1 over 4, or a quarter. As such, the question asks us to determine the two values of x that satisfies these two equations, and they are when x is equal to 0 or when x is equal to 1/4. And if you put them back into equation 1 and equation 2, you'll see that they worked out to be the same. When x is 0, in equation 1, y is 0. In equation 2, y is still 0. When x is equal to a quarter, and we put it into equation 1, a quarter squared is 1/16. 4 times 1/16 is 1/4. So y also works out to be 1/4 in equation 1. And if we put x is equal to a quarter in equation 2, it means y is equal to a quarter as well. May 2021, number 2A. Two quantities, n and t, are related as follows. N is equal to the square root of t. Part 1. Find the value of n when t is equal to 49. So let's write the formula. N is equal to the square root of t. And let's substitute. N is equal to the square root of 49 since t is 49. As such, n is equal to 7. And part 2. Make t the subject of the formula. So if n is equal to the square root of t, as we write that formula, we want t alone on the right-hand side, so we need to remove the square root sign. When we carry the square root sign across, we get the inverse of square root. What's the opposite of square root? Squared. So n squared is equal to t. May 2021, number 2B. Ali is X years. Jim is 5 years older than Ali, and Chris is twice as old as Ali. So we have 3 bits of information. Part 1. Write expressions in terms of x for Jim's age and Chris's age. So if we look at Jim's age, what information did they give us? They told us that Jim is 5 years older than Ali, and Ali is x years old, so Jim is x plus 5. And for Chris's age, they told us Chris is twice as old as Ali. So if Ali is x years old, Chris will be 2x. Part 2. In 2 years, the product of Ali's age and Chris's age, meaning that if we multiply whatever Ali's age is by Chris's age in 2 years' time, will be the same as the square of Jim's present age. Show that the equation x squared minus 4x minus 21 is equal to 0, represents the information given above. Let's write down a little table to show the present time what their ages are. Ali's age right now is x, Jim's age was x plus 5, which we got from part 1, and Chris's age was 2x. In 2 years, Ali's age will be x plus 2, Jim's age will be x plus 5 plus 2, which is x plus 7, and Chris's age will be 2x plus 2. So let's go back to the information they told us. They said the product of Ali's age and Chris's age will be the same as the square of Jim's present age. So let's write that information. Ali's age in 2 years times Chris's age in 2 years will be equal to Jim's present age squared. Let's substitute x plus 2 by 2x plus 2, we got that from the table, the right side table up on top, is equal to x plus 5 squared, because that's Jim's present age. And all we need to do is expand the brackets. So x plus 2 by 2x plus 2, if we say the first term by the first term, x by 2x is 2x squared. The first term by the last term, which is the outer terms, will be x by 2, which is 2x. Inner terms, 2 times 2x is plus 4x. And the last terms, 2 by 2 is plus 4. Is equal to x plus 5 by x plus 5. So 2x squared plus 2x plus 4x plus 4 is equal to x by x is x squared, x by 5 is plus 5x, 5 by x is plus 5x, plus 5 by 5 is 25. Okay, let's simplify these terms. So we're going to get 2x squared plus 2x plus 4x is 6x plus 4 is equal to x squared plus 5x plus 5x is 10x plus 25. And as we're trying to make it look like the proof has on one side equal to 0. So let's move all the terms across on one side so we get it equal to 0. So that will give us 2x squared minus x squared plus 6x minus 10x plus 4 minus 25 is equal to 0. And if we simplify, we're going to get x squared minus 4x minus 21 is equal to 0, which is the proof that they wanted. So we've completed it. So we could bring up a small rectangle to show that we've completed the proof. Or we can write QED, quod erat demonstrum, which is a Latin phrase which means that we have completed the proof that they ask us for. Part 3. Calculate Ali's present age. X squared minus 4x minus 21 is equal to 0. We know that. So if we solve for that, then we can find for x, which is Ali's age. And how do we solve a quadratic? Well, we could take the 3 terms and make it into 4. So let's multiply the outside, the coefficient of x squared, by the c value. 1 times 21 is 21. What else will give us 21? 3 times 7 will give us 21. So which of those pairs will give us minus 4? Well, the 3 and 7 will give us minus 4. So we can replace it. X squared plus 3x minus 7x minus 21 is equal to 0. And we can factorize the first 2 terms. So we could pull out x from it, and we're left with x plus 3. And we could factorize out the last 2 terms by pulling out minus 7. So we're also left with x plus 3 is equal to 0. So let's pull out now what's the same in both of them? The brackets. So we can rewrite it x plus 3, we have that in blue, by what's the remainder? X minus 7 equal to 0. So when we have 2 terms, when they're multiplying each other and it's equal to 0, either the first term is 0 or the second term is 0. So let's write that. So either the blue term x plus 3 is equal to 0, which means that x is equal to minus 3 years. And when we're telling the age of somebody, the age could never be negative. Or x minus 7, the green term, is equal to 0, which means x is equal to 7 years. As such, Ali is 7 years old. May 2022, number 2A, part 1. Factorize completely the following quadratic expression. So we have 5x squared minus 9x plus 4. And if we have 3 terms, we want to take the middle term, which we have underlined in green, the minus 9, and split it into 2 parts. So the 3 terms becomes 4 terms. How do we do that? We multiply the 2 numbers on either end, which is 5 by 4 is 20. So what we're trying to do is make a rectangle out of 20 blocks. So we can use a 1 by 20 rectangle, or what else can we make? A 2 by 10 rectangle, or a 4 by 5 rectangle. So which one of these rectangles or which one of these pairs will give us the middle term which we have underlined, minus 9? 1 and 20 can't give us that, 2 and 10 can't, so it will have to be 4 and 5. What we're going to do is write the terms 4 and 5 and manipulate the signs in front of it to see which one gives us minus 9, the green term. So plus 4 plus 5 is not equal to minus 9. And if we change the plus 4 to minus 4 plus 5, still not equal to minus 9. If we switch the signs and we have plus 4 minus 5, still not equal to minus 9. What about if we have minus 4 minus 5? Yes, that's equal to minus 9. So what we're going to do is we're going to rewrite that first line and split that term. So instead of 3 terms, we're replacing minus 9x by these 2 terms. So this will be equal to 5x squared minus 4x minus 5x plus 4. And now that we have 4 terms, let's take the first pair, which we have underlined in maroon, and factorize that. From 5x squared minus 4x, what can we extract? We can extract the x. So we're left with 5x minus 4. And from the next 2 terms, which we have underlined in purple, we can extract minus 1. So we're left with 5x minus 4. We could have also extracted plus 1, but we want to make sure that we end up with the same sets of brackets in both cases. Now that we have the same set of brackets, let's extract that. So our final factorization will be equal to 5x minus 4 by whatever is left, which is x minus 1. Part 2. Hence, solve the following equation. 5x squared minus 9x plus 4 is equal to 0. Now when the question says hence, it means go back to the earlier parts and see which one of those pieces of information we got to help us to solve this equation. And what we just realized in part 1, we will factorize the left-hand side of this equation. So let's rewrite the left-hand side. Instead of writing 5x squared minus 9x plus 4, we can rewrite it as 5x minus 4 by x minus 1 is equal to 0. So either the first set of brackets is equal to 0, 5x minus 4 is equal to 0. So 5x is equal to plus 4. As such, x is equal to 4 over 5. Or the second set of brackets is 0. X minus 1 is equal to 0, which means x is equal to 1. Thus, if we're solving the equation, the 2 possible values of x for this quadratic equation to work out will be x is equal to 4/5 or x is equal to 1. Part B. Make v the subject of the formula. So we have w is equal to 5 plus v over v minus 3. Let's rewrite it by putting in brackets in the numerator and denominator. So we'll get w is equal to 5 plus v in brackets by v minus 3 in brackets. So we can take the whole denominator and bring it across. So it will give us w by v minus 3 is equal to 5 plus v. And we can now expand the brackets. W times v is equal to wv. W times minus 3 would be minus 3w is equal to 5 plus v. And we want to find v. So let's make v the subject of the formula by putting all the v's on one side of the equation and everything else on the other side. So let's bring the v across. So we'll have wv plus v becomes minus v is equal to 5 minus 3w becomes plus 3w. And now we can factorize out the v. So we get v by w minus 1 is equal to 5 plus 3w. And if you want v alone on the left hand side, the brackets is multiplying. When we carry it across, it will divide, so it will end up in the denominator. So we end up with v is equal to 5 plus 3w all over w minus 1. As such, we have made v the subject of the formula. May 2022, number 2C. The height h of an object is directly proportional to the square root of its perimeter p. Part 1. Write an equation showing the relationship between h and p. Since they're directly proportional, we can write the equation h is equal to k, some constant, multiplied by the square root of p. Part 2. Given that h is equal to 5.4 when p is equal to 1.44, determine the value of h when p is equal to 2.89. So there are a couple different ways to do this. One way to do this is to recognize that in the formula there are 3 variables, h, k, and p. And in the first piece of information, h is equal to 5.4 and p is equal to 1.44. they gave us 2 bits of information. So we can substitute into there and solve for the third piece, which is k. So let's substitute. 5.4 is equal to k times the square root of 1.44. So 5.4 is equal to k times 1.2. And if you want k alone, we carry the 1.2 across, so it will be 5.4 divided by 1.2. So k, the constant of proportionality, is equal to 4.5. So when we rewrite our equation, h is equal to k square root of p, we now know the value of k. And they're asking us to find h when p is equal to 2.89. So we know p and we know k, let's substitute and we should find h. So h is equal to 4.5 times the square root of 2.89. So h is equal to 4.5 times 1.7. And we can use our calculator and this works out to be h is equal to 7.65. This brings us to the end of the CSEC past paper questions in the topic of algebra in section 1. In our first video in this series, we did past paper questions from May 2009 until 2013, and then from 2014 until 2018 was our second video, and this our third video from 2019 until the present. Don't forget to look at the description down below for you to get a good description of the order that you should be looking at all these videos to cover all the topics in CSEC Math.